Hello, this is Andrea, and in this video we're going to be talking about figures in 1 and 2 dimensions. We're going to start off here with talking about a little bit of vocabulary that might be important for these topics here. And we just start out with some basics that most of us know, but just in terms of the notation, sometimes it's it's one of those things we need to review. So of course a point we know is just a dot in any location. So if you were having to note or notate a point, you would just say point A. Okay, whatever it's labeled. A line, of course, is a straight path that goes forever and ever on both sides. So one thing that we see here is that we've got these arrows on both ends. And you may have, for example, 2 points that it goes through. So you may see something like this, that we have a point A and a point B, and we would call this line point AB. And a lot of times in notation we don't have the little dots written, so the notation might be something like this: AB with just an arrow with, or excuse me, a line with 2 arrows on each end, showing that it goes in both directions. Next we have array. So array actually does start out at 1 point, you can see, but then it has an arrow on the other end. So it just shows that it's a line that just extends in one direction. And once again, if we had, sorry, I should have called that A, even if B was really close, that's okay. That ray goes through line AB, so we would note that as just a line with an arrow on one end and say this is ray AB. And the order here is really important. We can't say ray BA because this ray does not start at point B, it starts at point A. So that's kind of important. That really is a little bit different than a line, because the line goes through both A and B above. So it wouldn't matter really if you called this line AB or line BA, but it does matter on the ray. Line segment, I'm going to go ahead and just put my AB here, and we can see that this is a part of a line. It's just like you had a line and you just cut off a segment of it, so it has 2 endpoints, and this is exactly how we would note that. We would basically just not have the little dots on the end. We would just kind of show a straight line, but it stops and there are no arrows. So this is line segment AB, or you could say line segment BA. All right, now let's talk a little bit about parallel and perpendicular lines. Okay, these are some things that we're gonna see in some of the homework. So parallel lines are lines that are the same distance apart, okay, which means they will never cross, okay, they never meet or never intersect because their slopes are basically exactly the same. A lot of times when you see parallel lines in some of your homework, I don't believe that we have that noted on NROC, but you may see this in some of your worksheets. We have like little arrows on the 2 lines that are parallel to each other, and that actually just shows us that those lines are parallel without having to say it. Another notation is over here on the left. We sometimes note that just with 2 parallel lines. Okay, so we may have like line A and line B, and we might say that line A is parallel to line B, something like that. Okay, perpendicular lines. So perpendicular lines, actually, they intersect at a right angle, or 4 right angles, right? 4 right angles. You can see here with this little box. This little box right here just means that this is 90 degrees or a right angle. Okay, and we know that because if we think about a circle, I'm just going to kind of draw a circle on here. If we think about a circle has 360 degrees, right? So if we were to cut this circle into 4 pieces, we could see we would have 4 right angles in there. Okay, each one of those sections or quarters basically are 90 degrees. When we have lines that, let me get rid of that there. If we actually have lines, let's just call this again line A and this one line B. We could say that line A is perpendicular, this notation here, to line B. Okay, we have that noted over here. Kind of just shows how those lines relate to each other. And then lastly, just intersecting lines. Of course, intersecting lines just means that we have lines that cross at one point, okay, and they form an angle. And of course, those angles could be any degrees, right? It doesn't necessarily have to be 90. It could be 90, but could be a lot of other degrees as well. All right. Now let's move on well, actually, you know what? Let's do something else. I'm going to go to your worksheet. We're going to come back to angles here in just a minute. Let me just practice a little bit of our kind of notation in terms of lines, line segments, rays, things like that. So let's go to number 1. This says identify each figure as a line, line segment, or a ray, and name it using the appropriate symbol. So we just remembered, or we just went over the vocabulary and kind of notations for these. You can see in A actually has a starting point here, right? Has a starting point, but then it has an arrow on the end, just on one side. So we know that this is a ray, isn't it? So it's definitely a ray. And we would note this basically then as, we know it starts at P, goes through Q, and it starts at one point with an arrow on one end only. Okay, so that would be the only way we would note that. And we could also just say this is ray. We could even do it all at the same time. This is ray P, Q, something like that. You could do it right next to the word ray. Okay, and B, looks like we have some points at both ends. You notice that line does not extend past those points. So of course this is going to be a line segment, right? This is a line segment. And we would notate that as AB with just a straight line above it. You could say line segment BA if you want to. There's really no starting point. It's just that they end at each one of those points. All right, let's take a look at C. So of course we can see there's arrows on both ends. So of course this is going to be a line. So we could have line RS, or you could say line SR. We usually go in alphabetical order. It's kind of more natural for us to do. Okay, so that's kind of how we would note those. I'm going to move all the way to 13 here. Let's move that up so we don't get distracted with the ones before. Okay, so sometimes when these lines are intermixed with a lot of other lines, sometimes it's a little bit harder to kind of figure out what we have. In number 13, it's asking to identify all pairs of parallel lines, okay? And we note the parallel, of course, with the little 2 lines there. Now, we don't necessarily have parallel lines notations down here. I added this right here. I added these arrows. It would be very helpful, of course, if those were there, because we would know automatically that those are parallel lines. But since we don't have those, so I'm going to take those off. We don't have that. So the only way that we know 2 lines that are parallel is these right angle marks that I have highlighted in red there. Okay, if both of those lines, so I'm going to highlight the actual line. So this line, EF, and line ID or DI, they both, or IJ, excuse me, IJ, both of those are perpendicular to this line right here, C. Let's just use a different color here. They're perpendicular to this line here, CD. And since that's the case, we know that the CD hits both of those other lines at exactly the same angle measure. So that's how we can tell that lines EF and IJ are parallel to each other. Okay, so we would just say, all right, this is line EF is parallel to line IJ. Okay, so that's 13, and number 14 asks us to identify all pairs of perpendicular lines. All right, so let me actually get rid of this highlighting here. All right, so let's actually go back and make sure we know that perpendicular lines hit at 90-degree angles in these little boxes. That's exactly what that means, right? So we have 3 of those here. Okay, so we know, once again, we said that before, that CD hits both lines EF and IJ at 90 degrees. Okay, so we can start there. So we basically will say that line, for 1, okay, line CD is perpendicular to this first line up here, which we had highlighted before. Probably should not have taken that off of there. Okay, and that one. I'm going to go ahead and highlight this one because we also are going to come back to that. So first of all, we're just going to go with this first line. So CD is perpendicular to line EF. Okay, that's the first one. We can see down here in this, our little box down here, that we know that line CD is also perpendicular to that bottom line, IJ. Okay, and thirdly, we can see right here in this highlighted, the right angle box over there, that line AB is actually perpendicular to this line right here, right, which is GH. So we have 3 different perpendicular kind of intersections there in number 14. All right, so I want to go back to the beginning here. I have a couple more kind of charts here that I want you guys to take a look at. This first chart up here is just talking about the types of angles that we have. So we have an acute angle, and we can see down below here that acute angles, their angle measures are less than 90 degrees, okay? I always learn them as a cute little angle because they're smaller than 90 degrees. Kind of an easy way to remember that. I'm going to jump over here to the opposite of that, obtuse. So obtuse, we can see the angle measures are more than 90 degrees. But I want to add to that. If I were to call this angle, let's just call this angle X. We would say that X is actually between 0 and 180. Okay, it can't be 180. We can see if we look over here on the right, a straight angle is exactly 180. So that's not an obtuse angle any longer. So we can say if we put X in the middle and we use greater than or less than signs, we can read this backwards and say that X is greater, excuse me guys, greater than 0, but it has to be less than 180 degrees. So X exists between 0 and 180, okay? And of course we could say the same over here if we were to call this, this X here. We know that an acute angle has to be greater than 0, but it has to be less than 90 degrees. I need to put my degrees in there because once we hit 90 degrees, we actually have a right angle. It's exactly 90 degrees, right? And as I kind of alluded to before, a straight angle is exactly 180, and we can see that, right? This is half a circle. This is half a circle. Right? I don't really like how that looks highlighted. We can show it's a half a circle because if we did the same thing on the other side, we would have a full circle. Not that my circle looks like a circle, my semicircle, but you guys get the point. All right, so those are some types of angles that we're going to be talking about. Now let's talk a little bit about the angle relationships. This is really the biggie in terms of this unit that we're going to get at, is how do these angles relate to each other, and eventually how do we bring in our algebra skills to solve for those missing angles. We call these relationships, one word for these relationships is identities. Okay, and you guys are going to be working a lot with this idea of angle or geometry identities or properties or relationships. And they're very helpful. If we know how these angles relate to each other, then we can find the missing angles because we know the relationship between 2 or 3 or 4 angles. Okay, we start out with just this simple idea of 2 angles here. We've got supplementary angles. This is a biggie, supplementary angles. So supplementary angles are 2 adjacent angles. Okay, and remember that adjacent over here, let's just skip real quick over here to adjacent angles. There literally just means that they're 2 angles next to each other. So supplementary angles are 2 angles that are right next to each other, and their degrees add up to 180. Okay, so they add to one of those straight angles that we were talking about above. Now, we often say, if I were to just name these angles as 1 and 2, like I did here, 1 and 2, we often say down here that angle 1 and 2, so angle 1 and angle 2 are supplementary to each other. We also can say that angle 1 is a supplement of angle 2, and angle 2 is a supplement of angle 1. Okay, so you will also see those words as you kind of go through your homework. Okay, supplement. So they're supplements to each other. If we move over here to complementary angles, you can see the same idea here, but complementary angles are 2 adjacent angles that add up to 90 degrees. Okay, so if we were to look at these, angle 1 is a complement to angle 2. Angle 2 is a complement to angle 1. And if we wanted to go beyond that, we can look down here. Angle 1 and angle 2 are complementary to each other. Okay, so that's the relationship between them. All right, and finally, in the end, I don't believe that NROC goes into this, but this is actually a really fun one, and it's a real easy one for us to use to find missing angles, is this idea of vertical angles. Vertical angles are 2 angles that are across from each other, formed by 2 intersecting lines. So you can see over here, we can see that angle 1 would be vertical to angle 2. We could also have 2 angles here, right? Let's just color these in. We could actually call this angle 3 and 4. Angle 3 is vertical to angle 4. Okay, and one other relationship here is I want you guys to know that vertical angles are equal measure. They're equal degrees. So vertical angles are equal. So we could say that angle 1 is equal to angle 2 in terms of degrees. Okay, let's just throw this measure of angle 1. Let's throw that in because what we really mean is the measure, the degree measure. And the measure of angle 3 is equal to the measure of angle 4 because those are vertical angles, because of that relationship. So these are the main ones that you guys are going to be using. There are a couple more that you will see that I am going to actually just show you because I think they're helpful. Here, of course, vertical angles, that is really important. The other one that you guys will use probably more often than the other 2 is corresponding angles. You're not necessarily going to be tested on them or anything, but these are really important to know. So corresponding angles just mean that they're sitting in exactly the same position when you have 2 parallel lines. So I'm going to just draw my little arrows. This is saying, I'm just going to call this line A, this is line B. And I'm going to call this line C. Line C is what we would call a transversal. So I guess I'll just do this. So line C, here is a transversal. And a transversal just runs through two parallel lines. Okay, so this transversal runs through line A and B, which are parallel to each other. When you have that happen, then you can actually look at the angles, and they also have some interesting relationships. Since A and B are parallel, that means that this angle here, that's sitting in exactly the same spot according to the transversal, those are equal to each other. So if we were to call these angle 1 and angle 2, we'd say the measure of angle 1 is equal to the measure of angle 2 because of the idea of corresponding angles. Basically, if we were to show this in another way, if we were to move B upward and a little to the right, just move that line upward, you can see that angle 1 is going to be sitting in exactly the same spot as angle 2, right? And if we had, let's say we had an angle here, right? If we move that line up, it would be sitting in that same spot. So those two angles are corresponding angles. And we have lots of them here. This angle that would be sitting down here would be corresponding to that one. And this angle down here would be corresponding angle to that one. Okay, so we have lots and lots of interesting relationships, and we can use this understanding of how these relate to each other when we're trying to write our equations, right? If we have two angles, but we have a bunch of x's, and they're asking us to find out what the degrees are, well, we can set those two angles next to each other, or excuse me, equal to each other. Maybe it was 2x, and maybe it was, I don't know, 3x plus 5. We could set those little expressions equal to each other because they were sitting in exactly the same spot. So we're using the idea of corresponding angles to help us to solve for the degrees. Okay. So that's a biggie. One of the other ones here that you guys will be using is this idea of alternate interior. So we have alternate interior and we have alternate exterior. Alternate interior angles are also equal. I'm just going to add this, so are equal. Alternate exterior angles are equal in measure. So once again, these have to be parallel lines that we're talking about, and then we have this transversal that goes through them. But basically, this is, so alternate, right, means kind of every other or across. You can see that this would just be basically, these are inside interior, these are inside the parallel lines, and they're just across the transversal from each other. Okay? We could also say that this over here, right, is interior. Those are both interior, and they're on the opposite sides of that transversal, so those are equal too. Okay, down here we have exterior. We can see that these angles are exterior. They're outside of those parallel lines, but they're also flipped across the transversal. We can also say that then this angle here that's outside, and this angle that's outside, right, those would be equal to each other because they are right across the transversal from each other as well, and they're situated outside. Okay, so all of these relationships are really interesting, very, very helpful to us when we apply them. They're kind of just little tools in our toolkit that we can use when we apply them to bigger problems. All right, guys, so keep these handy. You guys can do screenshots when you're watching the video. If you guys want to do that, I'll also try to post these for you guys. Let's take a look at some problems on your worksheet based on what we just learned. So let's take a closer look at number 3. Okay, it says identify which angles, if any, are the type listed. So here we have A. So A is obtuse. Okay, remember obtuse angles are between 0 and up to 180, right? They're not quite 180 yet. So we can see just by kind of looking at these that, let me go back to my yellow, that here D and B, right? These are fairly big angles, and so they're definitely bigger than the right angle, right? And they're not quite 180 degrees yet. So those are our obtuse angles. So those are B and D. Okay. Now we have B would be acute. We can see these angles right here, A and C. Those are smaller than 90 degrees, aren't they? So we've got A and C would be our acute angles. Supplementary angles. Okay, so remember what supplementary angles mean? They are exactly 180 degrees, aren't they? Right? So supplementary angles, let's see if we can find some. And really, we know that 180 degrees is half a circle. So if we can draw a semicircle with two angles, for example there, angle D and C, right? We know that those are supplementary, right? So we can say D and C, right? How about A and B? A and B, those would work, right? A and B. Okay, we'll get rid of that. We can kind of just shift our thoughts a little bit here if we were to look at B and C, right? It's kind of shifting around that circle a little, but you can see that those two angles definitely make or add up to 180. So we've got B, I'm going to just go up here, B and C. And we go to the other side, A and D. Okay, so we've kind of made our way around that whole circle there and looked at all the different combinations that would add up to 180, two angles that add up to 180. Now I want you guys to see down here in G, I'm just going to go down here real quick. It's asking for angles that sum to 180. Well, we already did that here, so I can just say same as C. Okay, how about complementary angles? So complementary angles, remember that those add to exactly 90 degrees. And we can see in our diagram here that we have none. There are no angles that add up to 90 degrees. All right, now how about E? It's asking for angles that have the same measure. Okay, so what are some identities that we learned? I'm going to go back over here. Some identities or some relationships that we learned. We don't have any parallel lines. We're not using this diagram here. But if we looked at some angle relationships here, we can remember this idea of vertical angles, right? Vertical angles that are right across from each other when we have two intersecting lines. We know that those are equal to each other, right? They're equal. Oopsie, didn't mean to do that. They're equal to each other. So let's go back here. And we do have two intersecting lines, don't we? We have line A and line C are across from each other. And we also have D and B that are across from each other, right? So we can list those. So we've got A and C, and we have B and D. And of course, vertical angles are the identity or relationship that we just used to find the answer for E. So we can basically use the same answer here, B and D. B and D. All right. So we kind of just went through that and extinguished all of our possibilities there. All right, let's go and talk about something else here. I'm going to go over to 11. I'm going to talk about that for a minute here, 11 and 12. Okay, so There's some notation here that was not on our charts that we kind of need to talk about. When we're naming angles, we name them with a vertex in the middle. So we have a vertex here in the middle. And a vertex is the point where the two rays of the angle originate. Okay, so I highlighted those in red here. And let's just look at number 11. You can see that F is kind of that starting point for ray FE and ray FD, right? So we name the entire angle, and we're talking about this angle right here. We name that entire angle with the F in the middle. It doesn't matter if you start with D or E. So we could name it angle DFE or angle EFD. Doesn't matter. The point is that you notice that our F is always in the middle of our angle when we name it. Okay? Same with 12. We see that Y is our vertex here for ray YX and our ray YZ. Okay, so if we're naming this entire angle, right, then we're going to say, okay, this is either angle XYZ, which comes very naturally for us because of the alphabet, or angle ZYX, noting that our Y is in the middle. Okay, so that's kind of an important thing for us to remember. All right, now sometimes finding these different angles, I wanted to just do number 15 briefly here. Sometimes when we're trying to identify certain angles, when we have a lot of lines going a lot of places, it can be a teeny bit confusing. So I wanted to take a look at number 15 for that reason. It's asking us to identify all obtuse angles, right? And if we remember that an obtuse angle is greater than 90 degrees but less than 180 degrees, so we need to actually look at the diagram and see if we can find one or more such angles. Okay, so let's do that. So if we take a look, what I want us to do is just kind of concentrate on the rays. So let's just start here. There's a ray going up here, right? We know that we can't use this ray here. We know we can't use that angle there because that is exactly 90 degrees, and we know that because of the 90-degree marker on the other side, right? The little box. But if we extended it down here, we can see that O would be our vertex, and we're really talking about this angle right here. It doesn't matter that line MP is running through the middle of it. It doesn't matter, right? We're still just looking at that angle that exists within that, right? So we can say that we know that angle NOQ, or you could have called it N or QON if you wanted to. That would be all right. So that definitely is an obtuse angle. Okay, and let's get rid of that notation. So we've got that one. Let's see if we can find another one. Okay, well, we know this would not work, right? This angle right here, because we see that's 90 degrees, right? So that's not going to work. Okay, but we can actually see here we have a ray that's going out, OM, the ray OM and the ray OQ, right? Those two rays form an angle in there. It does not matter that line NR is running through it at all, okay? And that opens up larger than a 90 degree. So we would just say, all right, the second such obtuse angle is angle MOR. Oops, not R, Q. Sorry, guys. MOQ. There we go. All right, so that's kind of how we go through and find all of the angles that they're asking for. Just got to just kind of keep looking and keep trying things. All right, let's jump to number 20 down here. So it says find the measurement of the following angles. Okay, so let's go in a little bit closer here to 20. And, you know, I want you guys to also keep in mind that because this is an algebra class, we're really starting to try to teach students how to show their work, show their algebra, show their steps. You know, by this time in the class, I know you guys are very aware of that I'm looking for your processes and your work. So we try to show it as best as we can. When you can, it's a really good way to kind of just show me that you're thinking through the process, or show me how you're thinking through that process. All right, so NOP, let's first of all figure out where that's at. So we're talking about N to O to P. We're talking about this angle right in there, right here. Okay, so how we do that is we start to think about relationships that we know, the angle relationships that we know, right? And we use what we can see in our diagram and our ideas about the relationships, okay? So one thing that we can see here is that we have this right angle measure over here, which means that the other side is also a right angle. So what that really means here is that we can look at this angle NOQ. We know that, it's not a G, it's a Q. NOQ, we know that that is 90 degrees, right? And if we subtracted this piece here, because it gives us the degree measure of that, so I'm just going to do the notation up here and we can fill it in with the actual degrees below. So that angle would be POQ. So we're going to subtract that out, which is 32 degrees, right? Then it's going to leave this angle that we're looking for, NOP. Okay, so 90 minus 32 is going to give us our value, 58 degrees. Okay, so we know that angle NOP is 58 degrees. And here, down here, is the work that we can show. Now, you guys may show your work a little bit differently than me. That's okay, no problem, as long as you're just showing me kind of how you're finding that. And I really want you to kind of get in the habit of setting up an equation, right? Set up your equation if you can. If you look for those relationships, right? Set up your equation using your relationships or your identities. Kind of get used to that word because we're going to be talking about geometry identities a lot coming up in Unit 7. So we're setting up our equation, and then of course we just solve for the missing angle measure. Angle measure. Okay, that's kind of what's going through our brains as we're attacking these problems, or I should say approaching them. Maybe we're not attacking them. All right, let's take a look at 21. All right, so 21 is in the same set of directions. It's asking us to find the missing measure. So it wants us to find angle ADB. Okay, so let's identify that, ADB. So we're looking for this angle measure right here. We kind of stand back and we're looking for what relationship do we have, right? What relationship can we use to find the missing angle? Well, we can see if we look at the kind of overarching kind of relationship here, both of these angles, ADB and ADC, form a straight angle, right? So these are supplementary to each other, aren't they? So we know because of supplementary angles, right? We know supplementary angles add to 180 angles equal 180 degrees. We can use that identity, so we can literally say, all right, we know that 180 minus 80, because they give us this part of it here, don't they? Minus 80 degrees is equal to 100 degrees. And we know that based on our supplementary angles. This is the identity that we're using, or the relationship. Okay, let's take a look at 23. Identify the angles below. Name two angles that are complementary to each other. Okay, remember we talked about that when we have complementary angles, right? Complementary angles add up, of course, to exactly 90 degrees. And if they're complementary to each other, we're just looking for both of those angles when we're going to name both of those angles. All right, so luckily they help us a whole lot here. In fact, without this, guys, that's one thing that I've gotten in trouble with earlier on in my math education. I would look at a diagram and I would assume something was true. For example, I might look at something like this and say, well, that's definitely a right angle. And I would use that to answer the bigger problem, right? But the deal is I'm assuming that this is a right angle unless it shows me by either that or by literally stating that this is 90 degrees, okay? So if it doesn't have that on there, don't assume that it is, even if it looks exactly like a certain degree. That is a kind of a mistake that we all make sometimes, and it's really easy to make. All right, guys, so we can say, let's just say this is angle 1, this is angle 2. Sometimes you'll see that with, if we're noting different angles, we know they may not be. In fact, most likely they're not the same degree, so we put one line for one, two lines for the other, stating that they're not the same degrees. But we do know that if we're asked to find two angles that are complementary to each other, then we can just say, okay, yeah. So angle VOW and angle WOX, right, are complementary to each other. And we know we have to keep that O in the middle, don't we? Because that right there is the vertex of both of those rays. Okay, we can go ahead and do this last one down here. Name two angles that are supplementary to each other. So the same idea. We want two angles that add, right, to 180 degrees. All right, so we can look at this in a couple of different ways, right? You guys, there are a lot of choices here. We could do, in fact, I'm just going to draw them. This is kind of the fun part of it. Maybe it's fun for me, maybe it's frustrating for you guys, but so that's one option. Here would be another option, right? Let's use a different color. Here would be another option. There's three angles there that we could add together that would be supplementary to each other. There's actually three there, right, that create that 180 degree or straight angle. Okay, I'm running out of colors. How about this one? We got those, right? There's so many here. So what you could do is, you notice here it's just asking you to name two. So just name two of them. Okay, whichever ones you see, whichever ones you want to do. I'm just going to just state here the angle CDG. So I'm going to get rid of all of this. There's a whole lot going on there. I'm just going to start here with CDG and that, since that's kind of the first one that I saw. So CDG, oh my goodness, DG, and angle CDF. There's one. You guys could choose whichever other one you want to. Let's just do that. So angle CBF or DF, sorry, CDF, and okay, so we're looking at that one, and then this little one down here, which would be FDE, or let's do EDF, angle EDF. There's two of them, but like I showed before, you guys, there's a lot, so you guys can decide which one you want to list there. All right, now finally let's go back here. One of the goals, the big goals of this class, this unit here, well, yeah, the class is, of course, this is an algebra class. So one of the goals for our unit with geometry is to use our algebra along with the geometry relationships that we have to solve for the missing angle measures, like I said before. We're really looking at that. So here's where we're kind of starting this idea in number 4. We're starting this idea and we're asking you guys to set up an equation and solve, just kind of like I have modeled for you in some of the other problems. You're going to be doing a lot more of that on worksheet number 19, and in fact have some activities based on that. So let's take a look at A, and we'll start there and just kind of see how we do that. So one of the first things that we want to do is we need to ask ourselves, number 1, I'll just kind of do that here. What is the angle relationship or identity? Okay, that's our first question. What is the identity or the relationship that's going on here? And if I can identify that, then I can use that as my equation. Okay, so in A, we can see this is a right angle. It tells us so with the little box. So we know that these are complementary angles, right? These are complementary. And we know that complementary angles add up to 90 degrees. That right there, that identity or that relationship is how we set up our equation. We use that in A to set up our equation in B, or number 2. Okay, and of course then we make sure in number 3, we want to make sure that we are answering the question. I'll show you what I mean by that. We're not just solving for A, we need to, well, in this one it's asking us to solve for A, but sometimes it'll actually ask you for the angle measure, so you have to be kind of careful. All right, so we know complementary angles add up to 90 degrees, so I can say here A, right, A plus B, and I can put a little parenthesis on it if I want to. I know that A plus B plus this angle down here, which is A plus 20, have to equal 90 degrees, right? And then I'm just solving. I should have just put that in there, solve. Number 4 would be make sure to answer the question. So we can solve this. We know how to do that. We've got algebra skills, right? So we have 2A's plus 20 equal 90. We'll subtract our 20 from both sides. 2A is equal to 70, right? And we just solve here for A. So we find that A is equal to 35. And of course, we use our degree measures because we know that this is, that's our unit that we're talking about here. Okay, so if we go back to the question, we can see, okay, it's literally just asking us for the measure of A. So let me get rid of some of this up here. I've got a lot going on. I'm going to use a different colors. A lot of red going on here. I'll use blue here. So this is 55 degrees. All right. And then of course, since we know that that's true, and we could just also stick a 55 in here for our A, right? 55 plus 20. So we know that this angle right here is 75 degrees. Then we can, whoa, what happened here? Oh, minus 20. What? That's not right, guys. What did I do? 70. Oh, 35. That's why. I'm like, Okay, well, actually, it's probably good that I did that. If that ever happens, that I guess shows how important this is to check your work. Because when I stuck in 55 there, definitely didn't add to 90, right? And these need to add to 90, so I would double check your work, right? 35 plus 20 is going to be 55 degrees. and 35. So then, yeah, we can check. Yeah, 35 plus 55 degrees equals 90 degrees, and that checks out. So we know that we did that correctly. All right, so I know I wrote these before. I'm going to erase all this except right at the end. If this question had asked for the measure of both angles, right, we would have to do what we did on our check, where we plug in that 35, we add the 20, and we would have to answer those questions. So one is 35 degrees and one is 55 degrees. So make sure that you're reading what the question is asking you. And whether it wants the just the measure of the variable or whether it wants the measure of the angle. All right, let's take a look at B. So B, we have a lot going on here, and I like this question because what it shows is that you guys can use, sometimes you guys have choices in the relationship or identity that you choose. For example, in this question here, we could use the idea, so obviously we're supposed to solve for angle A, B, and C. You could use the idea of supplementary angles, couldn't you? For sure, absolutely. But the other thing that you guys could decide to do first, if you wanted to, is vertical angles. And sometimes you need to do both, right? Sometimes you actually need to figure out both. So it doesn't really matter where you start. I would say maybe let's start with supplementary. So we're just going to do number 1 here. So because of supplementary angles, we'll do a little bit of abbreviating here. I know that angle C plus 37, and let me just take the angle off, because if we're doing algebra, we don't need that little angle measure in there. I know that C plus 37 has to equal 180 degrees, right? Okay, so let's just solve for C. Okay, so C would be 143. And I could go up and just put that in there. All right. And then because of vertical angles, and it's kind of a good idea for you guys to write out why why are you setting up your equation as you do. It's really great when I can see, oh, you're saying because of supplementary angles, this is why you have this equation. And now because of vertical angles, we know that angle A is equal to 37 degrees, right? We know that based on the relationship of vertical angles. We also know that angle B is equal to 143 because angle B is the same as angle C, right? So because of vertical angles, we were able to solve right there for those other angles. So right here we have our 3 answers. The first one was because of supplementary angles. The other 2 were because of the idea of vertical angles. Okay, move on to C, this last one here. All right, and this is one of those questions where you may use those relationships that we talked about last that maybe are not ones that we would typically see, but ones that that are helpful if we know them. So in C, we're looking for angle A, B, and C, and they note here that lines M and N are parallel to each other. Okay, so we can actually note that. So we have a transversal that's going through 2 parallel lines. Okay, so we just start looking for relationships. Of course, they give us this 121 degrees down here, which is really helpful because we could start out here with this idea of supplementary angles, right? We know that let's just start here. We know that because of supplementary angles, that C plus 121 degrees has to equal 180 degrees. Okay, so we know that C is actually going to be 59 degrees. Okay, so we can just plug that in. I think what I'll do is get rid of that. Okay, so that's equal to 59 degrees. All right, now we kind of start looking for other identities. You know, we don't have a situation where we can use anything else in terms of vertical angles, complementary angles, but we do see that we have some alternate interior angles here. You notice these are both inside the parallel lines and across the transversal from each other, right? So because of alternate interior angles, okay, we know that angle B is equal to angle C. Therefore, angle B is 59 degrees. Okay, so here's our second answer. Okay, B here is 59, right? And we can also say the same for here, right? This angle and this angle are alternate interior angles, right? Therefore, we know also, let's just say and, we know that angle A is the same as 121 degrees, which is our last one to solve. And we could have checked that too, right? We could have said, oh, I'm not sure, you know, I'm not sure if I feel really comfortable with that. Let's just go with this idea of supplementary, right? We would have said, okay, angle B and A have to add to 180, right? So if we wanted to even just check that, we could say, all right, so 180 minus 59 has to be what's remaining, which we would see as 121, and that would have been our A. Okay, so we can check in different ways. And you know, sometimes this is like it's kind of like if you're crossing a stream and you got to just jump on one big rock and go to the next and go to the next. Sometimes it's like that, where you just start with something and you work your way across so that you end up being able to answer the questions and find the angle measures for everything that they're looking for. Okay, guys, so this is just a little bit of a lot of things, but the idea is for you guys to just start really looking at the relationships between these angles and start to use the algebra to solve for all of the missing angles. All right, so we'll look for the next video for the next worksheet, which is going to go into a lot more detail about angle identities. All right, talk to you later.